Hey guys, we're going to be continuing on with 8.3c, using Trig to find angle measures. So yesterday we used Trig to find the sides. Today we're actually going to find angles. So again, you can use this in multiple different ways. You still use the same trigonometric ratios. So that part, again, that's why we spent so much time on it in the beginning, is still going to be relevant and true. So again, that part's still going to be applicable. Let me move myself out of the way here just a second. But again, I can use trigonometric ratios to find, should have been to find, unknown angle measures in right triangles. So we've got a few examples here, but first thing I want to do is I want to go ahead and just remind you again of SOHCAHTOA. Again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then, of course, tangent is opposite over adjacent. Okay, so that's going to be important anytime we're talking about trigonometry and using trigonometry to find either sides or angle measures. Today, again, we're focusing on angle measures. So if you notice on number one here, we're given this triangle NMO. And in all of these examples, we're going to be finding the measure of angle M. So this is really the question mark right here. Sorry, that looks awful. Question mark. This is what we're really looking for, okay? So if you remember from yesterday or the day before, when we were talking about finding sides, we kind of made sure that this measure was with our trig function, okay? So we're going to talk about that here in just a minute, but we got to figure out what trig function we could actually use because we got 3 different ones we could use, right? So first, let's identify, and maybe the best thing to do always is to see if you've got the hypotenuse or not. And in this case, we do. You see your right angle, right here's your side across from that. So we're going to go ahead and identify that as my hypotenuse. Now, if we're talking about angle M is what we're really focused on here, then this 4, is it adjacent or is it opposite of angle M? And you got to be careful here. So remember, this angle is made up of this. So across from that would actually be over here. So we're not opposite, we're actually adjacent to it, okay? So now let's think about what trig function has adjacent and hypotenuse in it. Well, the only trig function that has adjacent and hypotenuse in it is cosine, okay? So in this particular instance, we're going to do cosine of, and we'll label this as x, I guess. We don't really know what that is yet, but we do know that our ratio is adjacent over hypotenuse. So I'm going to have 4 over 14. The issue here is I do not know what this angle measure is. And this angle measure is connected to cosine, right? The problem is it's not really connected through multiplication, even though it kind of looks like that because it's right beside of it. But they're connected, and I need to find a way to undo this. Well, the way to undo multiplication is division. The way to undo addition is subtraction. But what are those called? Those are called inverse operations, right? So inverse operations is basically what you have to do to get this cosine. You can't just divide by cosine because doesn't really make any sense. It's connected to this degree measure, but in order to figure out what that degree measure is, I'm going to have to do inverse operations to get cosine over here away from the x, right? Well, believe it or not, your calculator actually has this already on it. And if we think about it, it'll make perfect sense. So what I have to do in order to get cosine over here is I have to do the inverse operation. So here's the way you would write that. X equals cosine of -1, raised to the -1 power. Well, let's just think for just a second what happens when you take something to the -1 power. For example, if I had 2 to the -1 power. The way I resolve that negative is I actually put it under a 1. So it's like a reciprocal, okay? Again, like an inverse. So anytime you see this cosine of the -1, that is something that you use when you're trying to get cosine to the other side or you're trying to find an angle. As a matter of fact, it's called an inverse trig function. So instead of just regular old cosine, where you really use an inverse cosine to try to figure out what the angle is because we do not know what this angle is. Now, the part that's with this is this 4/14 that we kind of already had figured out. So it's really just as simple as this. We're going to go over to our Desmos calculator. Again, it seems like I always got to move myself out of the way, but it's all right. And again, I'm looking for this trig function, right? I'm looking for inverse cosine. Let me go back to our notes. Notice this is what I need to input into my calculator. So I'm going to go to my Desmos calculator. And again, if I go to functions, notice here I have sine raised to the -1 or inverse sine. I have inverse cosine and I have inverse tangent. So I need inverse cosine, and notice it goes ahead and gives me a parenthesis. So it's ready now for me to put something in there. And here I can just simply put in my fraction that I had, 4 divided by 14. Sorry, that did something crazy. I don't know what it did, but it did something nuts. All right, let's make sure we're inside of there. Okay. 4 divided by 14. And notice what it gives me. It gives me 1.28. But now I have to ask myself, am I in degree mode or am I in radians mode? And notice right here, always go to this little wrench right here and make sure that you choose degrees. Okay. And 1 degree just really didn't make sense. Okay. Again, use some logic here with what's going on. And so this told us to round to the nearest degree. So this 0.3 would just simply stay this 73 to stay the same. So we can confidently say now, sorry, I keep kind of skipping around. We can confidently say now that x equals 73 degrees. All right, let's work through another one because I think that'll help us here. Here, we're looking for angle M. So I'm going to go ahead and put my X right there because that's really what I'm looking for. And so let's think about what trig function we need to use in order to make this happen. Okay, so this 2, you will notice, is opposite of my angle X here. So that means that this either has to be adjacent, which, look at this, it does share a line, or it is the hypotenuse. Well, if I look really close, I can see this is in fact the hypotenuse because it's across from my right angle, okay? So again, what trig function do I need to use here? I've got opposite and hypotenuse, which is sine. So I'm going to write it out a lot like I wrote out this one. Sine of x, I don't really know what it is yet, is opposite, which is 2, over my hypotenuse, which is 5. So again, you can see how those ratios, they just keep coming back again and again and again, but it helps you to be able to solve the problem. Now I need to get sine over here, but remember I can't multiply, divide any of that by sine because I'm looking for the angle it's attached to it. So I have to do inverse sine. So sine to the -1 of 2 over 5. And again, I can go right back over to Mr. Desmos. I go to functions, inverse sine, and again, what was those values? 2 divided by 5. So literally in here, I just do 2 divided by 5. And now I'm in degree mode. The 5 is going to tell this 3 to go up. So that actually means that this is 24 degrees, okay? Let's go ahead and work out one more problem. I will just go ahead and, oops, not that. I'm going to go ahead and erase this. Let's go ahead and just clear it out. So let's clear out the canvas. And we got plenty of room here now. And let's go ahead and write out number 3, or draw out number 3 for today. Again, right angle right there. And here I have C, G, and M. I have 125 here, and I have 41.25 over here. And again, I'm looking for angle M. I'm looking for this angle right here. So we'll call that angle X, okay? And so again, I'm thinking about my trig functions and what I really have. So you notice that this 41.25 is in fact opposite. And this 125, it either has to be adjacent or hypotenuse, but my hypotenuse is actually this long one that is across from my right angle. So that means this has to be adjacent. Now, what trig function, this is a little quiz, what trig function does not use the hypotenuse? There's only one of them. It's tangent, right? Tangent is opposite over adjacent. So in this case, I'm going to use tangent of x equals opposite over adjacent. My opposite is 41.25. My adjacent is 125. So that's going to be what I put in Desmos. Inverse tangent, 41.25 divided by 125. And you notice my angle measure that it comes up with automatically is in fact 18. So x equals 18 degrees. Ladies and gentlemen, it's as simple as that. Again, if you're finding sides, you're going to use just the regular trig functions, sine, cosine, or tangent. But if you are finding angles, you're going to end up using inverse tangent, okay? You're going to use your inverse tangent in order to be able to find these answers, okay? If you need help, make sure that you reach out to us, guys. That's what we're here for. So make sure you reach out to us because we want to make sure you get this and that you do very well on this upcoming test that we have probably coming up next week. So talk to you soon.